concat is a method that you call on an existing array, and it returns back to you a new array that has the original plus any parameters you pass in here. Let's see this in action. If we create an array with 2 items and we wanted to add a third item to it, we can use concat. We say new items equals items.concat 3. So items is the original array. All arrays have a concat method, which takes a copy of this original array, adds to it any parameters you pass in here, and returns a new array. So if we log this to the console, we should see 1, 2, and 3. And there you have it. So that's the basics of array concat. Now let's look at a few other features. You are not limited to a single argument. You can provide as many here as you like. And they all get added to the array. You're also not limited by type, so you can add a string if you like, or an undefined value. Any number of items here is okay, and they all get appended to a copy of the original items array. One of the more interesting features of concat is that it can actually take in other arrays. So for example, if we provide another array inside here with the numbers 3 and 4, we actually get the same result as calling it with 3 and 4 separately. This is because concat looks at each and every argument, and if it's an array, it will pull out each value from that array and add it to the original. This works with multiple items as well. So here we're starting with one array, we're picking out the values from this array and this array, and we end up with a single flat array. Again, you can mix types, so that will work also. The one limitation which can trip people up is that you cannot do nested arrays. If we were to nest 2 of these inside another array and run that, you'll see we actually get those 2 as an array. So that's just one thing to keep in mind. It can flatten arrays, but only one value deep. Now we'll look at a more realistic example of how you might use concat in your application. Let's say you have an array of objects, where each object represents a person with a simple name property. If you wanted to do something with each person, you could call for each. We'll just console log person.name. You can see we get Shane and Sally. Now, if we had another array of people, maybe it comes from a different source or it's generated from user input, we'll call this people 2. And we'll say it's Simon and Ben. We wouldn't want to simply duplicate this code for people 2. Although it would work, a better way would be to use concat. So we can take the original people array, call concat with people 2, and then call for each. So this works because if you remember from the beginning of this video, when you call concat on an existing array, it takes the original array, then it looks at each argument. If it's an array itself, which this is, it will pull out each value, in this case each object, add it to a copy of people, and return a new array. So by the time we get to this line, we're actually acting on 4 items. We're acting on these 2 and these 2, which is why we get Shane, Sally, Simon, and Ben. Array join produces a string that is the result of adding together all items of an array. Take this example. If we wanted to output this full name with a space in between, without using join, you would have to do something like access the first item in the array, add an empty space, access the second item, and that would work. This is extremely fragile, however. Just adding a middle name can break it. Now it's not what we expect. You could fix that by accessing the third item. But if you wanted all names, you would have to go back and add in another space and access the next item. And this is basically a terrible way to write a program. It's not scalable and it's extremely error prone. It's also exactly what array join is designed for. Really what you want here is to say, however many items there are, give me them all back as a string, and I want to provide the separator or the glue in between. Well, that's how join works. You call it on an existing array, and you pass along what you want that glue or the separator to be. In our case, we just want an empty space, so we pass a string with an empty space. And there you have the same result. The difference here is that it's completely dynamic now. So the amount of items in the array doesn't matter, it will always work. You can provide any value here. If you want the elements to be joined without a space, then you simply provide a string without any character inside it. If you don't provide any argument at all, the elements will be comma separated. This is not coming from here. The comma is the default argument to join, so if you don't provide one, it will be used. Now let's look at a practical use case. Let's say you have a command line program and you want to provide a help screen to users. You could store each line of the help text in an array. Then you can check if the user has ran the help command by looking at the third argument available to us on the process.argv property. If they did, we want to output the help text to the screen. So we can console log help. This time we use the join method with a new line character. So this will take every item in the help array, put a new line in between each one, and output the result to the console. If we move over to the terminal and run this command, you'll see we get our help output. That's basic join functionality. You can also chain it with other array methods. Similar to our first example, if we had a name instead that was already a string, and we wanted to uppercase each letter here and return back a string, we could first split the name on any space. Then we can map over that and return the first character uppercased along with the rest of the string in its normal form. And then finally join it back together. If we save this to a variable and then log it to the console, you can see we get the desired result. So calling split on this creates an array with Shane and Osborne in it. Then the map function runs for each item in this array, which produces another array with the items Shane and Osborne. Finally, calling join on this using an empty space creates this string. Indexof is used to search an array for a particular value. If we wanted to know if Kitty existed in this family, we could console log family.indexof Kitty. Doing so would yield the value 3, meaning the search was successful and this value exists at index 3 in this array. If the search was unsuccessful, we see -1. -1 is always returned from indexof when the search fails. So if you need to perform an action based on whether or not an item already exists in an array, you can check the value of indexof. If it's above -1, you know that element exists. You could save the check to a variable. So we'll say kitty exists is equal to the indexof check being greater than -1. So this expression will return either true or false based on whether or not kitty already exists. Now we can log kitty exists and we see false. And if we add her back in, we get true. So now we have this flag. You can do things like if not kitty exists, family.push kitty. Log the family again. And you see we only have one instance of kitty as she was already in the array. But if we remove her, you'll see she's still there. Indexof in this case returned -1 as this was not found in the array, which in turn sets this to false, which means that this block of code ran and it added kitty back to the array. Indexof has a second parameter, which is the start position of the search. If we add kitty back in here and run this, as before we get 3. But should she be in another position in the array, let's say second, and we provide a start position for the search being 2, now we get -1. This is because specifying 2 here starts the search at index 2, which is 0, 1, 2. So only these 2 items are searched. If we were to change this to 1, the search will now begin here. But note the value we receive here, 1. It doesn't matter where you start the search in the array. If an item is found, you will be given the index relative to the whole array. You can also search for object references and other values. So if instead of using simple strings we had, say, 3 objects like this, we could create a family variable that is an array containing Shane and Sally. Just like before, we can search this family to see if Kitty exists in it. This time, instead of searching for the string, we're searching for an object. And you can see we get -1. If we add her to the family, we get 2, which means Kitty was found at index 2 of the family array. To finish off, we'll look at how to use indexof to create a filter. We'll filter this events array based on whether or not the extension of any of these files matches anything in the whitelist. So we have CSS and JS here. We want the result to be an array that contains these 2 and not this one. If we set up a new variable called filtered and then call events.filter, we can use the path module to get the file extension. And then to check if this item is part of the whitelist and therefore should be allowed in the filtered results, we simply return whitelist indexof extension greater than -1. Remember, indexof returns -1 if it doesn't exist and anything from 0 and upwards if it does. So this filter method now will only allow through items that have extensions that match the whitelist. If we log this out, we can see that's the case. Array slice creates a shallow copy of an array. So if we want to copy this, we can simply say copy is equal to items.slice. And if we log it, we can see that is indeed the case. Now, because it's a copy, anything we do to this second array won't affect the first. If we were to push another item onto the second array, and then log both arrays, we can see the difference. So the first is untouched, but the second now has 6 items. The same thing applies for modifying existing items. So if we were to instead access the first item of the copy array and change the number to 100, when we log them both out, you can now see the original still untouched, but the copy has 100 in the first slot. So this brings us on to explaining what a shallow copy really is. If the original array contains numbers and strings, when you call slice to create your new array, it will literally copy the values. But if the original array contains object references, the reference itself is copied, not the object. To demonstrate this, let's create a person. Let's just got a name of Shane. And we'll stick that alongside one of the numbers. Again, if we log both out, we can see we have the number 1 and an object. Now, here's the important difference. If I were to access that person object in a copy, which lives at index 1, and change the name property to something else, you might expect it would only affect this copy. Well, let's see what happens. You can see here that the original items array has now got the updated value, which proves that even after calling slice on the original array, if one of the values is an object, it doesn't look at each property and create a new object inside that matches it. It actually just copies the reference to it. And that means if we were to access it again from any of the arrays and change the value, because both arrays still point back to the same place, it will modify both. A more common use case for slice is not to simply create a copy, but instead to take a subsection of the array. So let's just go back to a simple array of numbers again. Slice can take 2 optional parameters, a start and an end. So if we were to provide 0 here and 1, this is saying begin the slice at index 0 here and go to index 1 here. The end parameter never includes the item that you're ending on. So if we were to log this, we would expect the number 1, as we see there. So this is the start index and this is the end index. If you wanted the first 2 numbers, you could change this to 2 or more. If you provide a start without an end, in this case we're saying start at 0 here, then it will take everything else in the array up to the end. So no matter how long this is, you'll get everything after the index you specify here. So if we say start at index 3, it's going to move along to here and take the rest of the array. You can combine this with an end position, so if you want to go from 3 to 6, then you can pull out a subsection of the array. You can even use negative numbers here. So if we were to start at -1, a negative number makes the start position count backwards from the end. So -1 means go to the end, go back 1 item, and then begin the slice. So if we change it to 2, it goes 1, 2, and then slice. You can also provide a negative number for the end. So let's say we wanted numbers 2 to 7 from this array. We can start at index 1 and end at index -1. And you can see we get 2 through 7. Now on to a practical example. Here we have a person object. Then we have some filters. The first one, deslugify, simply replaces any hyphens with an empty space, and uppercase turns any value into uppercase. Now we want to process some input, a bit like an angular filter or filters you may have seen elsewhere. We have some input like this. So we'll say name that refers to this. We're going to pipe it through deslugify and then through uppercase. We first need to split this input up into sections. So we can say var sections is equal to input.split and split on the pipe character. Some of these may have white space here, so we can simply map over each of those and call trim. If we log this out to see how far we are, you can see that we now have name, deslugify and uppercase. Now we know the first item in this import is going to be a reference to a property. So we can say reference is equal to person sections 0. And if we console.log ref, just to make sure where we are, we can see we have Shane Osborne. So now is where we get to use slice. We looked at before providing an index as an offset and then taking every other item in the array. Well, if you remember that right here now we have name, deslugify and uppercase. We can't be sure how many filters there will be. We can just say start at index 1 and go to the end. So we can start building up our output by saying sections.slice 1, which will give us an array that contains just slugify and uppercase. Then we can call reduce, and there we have a previous item and a next. We can start this reduction off with our reference. So the first time this function is called, previous will be equal to Shane Osborne. And for each time it runs, next will be each item in the filters array. We can just do a quick dirty check to see if the filter exists here by simply saying if filters next. You may want to do more robust checking in your own app, but this is good for demonstration. So if a function exists that matches the name of one of these, we can return the result of calling that filter with no context and the previous value. Remember, the previous value is going to be what we passed in here, which is our reference, which is this. If the filter did not exist, we'll simply return the previous value. If we log our output now, you can see we get the desired result. So first of all, we split this input on a pipe character. We trimmed the white space. Then we saved the first item and looked up our reference here. Following that, we sliced off however many items existed after the first one, which produced a new array containing just these two items. Then we call reduce, starting with our reference. For every filter in our array, we check if a function exists. If it does, we pass the previous value into it, and we end up with a single result in the end. Array sort sorts the elements of an array in place and returns the same array. So if we wanted to alphabetically sort this array of names, we could simply call items.sort and then log items. And you see we get the desired result. You can do the same with numbers. So if we had 10, 30, and 20, that appears to have worked. However, this is not what you expect. When calling sort on an array with numbers, what actually happens is each number is converted to a string and they are compared using their position in Unicode. We can demonstrate the problem this causes by placing a 2 here. So now we would expect that 2 is the first item, 10 is the second, and 20 is the third, 30 the fourth. But when we run this code, we see a very strange result. We have 10 first, then 2, then 20 and 30. This is because in Unicode, 10 does come before 2. Again, this is because these numbers are being converted to strings first. So to perform a numeric sort on an array such as this, we need to provide a comparator function. The comparator has A and B being the left and right item of the sort algorithm. And to sort this array in ascending order, we can simply provide A minus B. And we get a correct sort. By providing a comparator function here, you are taking over how two values are compared with each other. So whereas previously these numbers were being converted into strings first, inside our comparator function, we just get the raw values. And that allows us to simply subtract B from A and return the result of that subtraction to the comparator function, which is then used to determine what action should be taken on the current item. The reason why something so simple as this works for a numeric sort is that this comparator function only cares that you return either 0 or a value less than 0 or a value above 0. For example, the longhand version of this might look something like if A minus B is exactly equal to 0, return 0. If A minus B is less than 0, return minus 1. And if it's more than 0, return 1. If we run it again, you see it still works. But the interesting part here is that this number can be anything that's below 0, and this can be anything that's above 0. And that will still work. So this explains why simply minusing B from A works. So if we console log that, we can see it in action. You see we get some negative numbers and some positive numbers. So when the underlying algorithm that's performing the sort calls this comparator function, it really only cares if the value is either 0, below 0 or above 0. That's why you can reduce all of this down to a simple expression A minus B. To perform a descending sort, you would simply provide B minus A instead. We can make use of this comparator function in multiple ways. For example, if we go back to having an array of names, this time we've added in Kitty, and we wanted to sort this array based on the length of the string. Well, in this case, each value inside the comparator will be a string. Strings have a length property, so we can compare that instead. So now you see we have Kitty at the front, as we are using B minus A, which gives us a descending order. Now let's look at a slightly more useful example. Let's use an array of objects, where each object represents a lesson that has a title and a views count. We want to sort this array based on the amount of views and then output some HTML. We'll first create the list by sorting the lessons based on the amount of views. We want it to be in descending order so that the most popular video is first. So we'll call b.views minus a.views. This will give us back an array on which we can call map. And then we'll simply return a template string. We'll indent each line with 4 spaces. Then we'll create an li. Inside of here, we'll say x.title space, and then in brackets, we'll use x.views. Finally, we can join that together with a new line character, which will make up our list. Then we can create an output variable, which is another template string, which is a UL, has a new line, then our list, and then another new line. If we output this to the console, you can see we get the output we expect, which is a list of our items that have been sorted based on the amount of views. So to recap, we take the lessons array, we provide a comparative function to the sort method, which sorts each lesson based on how many views it has. Sort gives us back the same array, although now modified. Then we call map, which is called for each item of the array. We apply a little bit of padding just for the sake of output here. Then we access the title and the views. We join those together with a new line character. And then we wedge that in between a UL with some more new line characters, which produces this output. Array filter creates a new array. It does this by calling a function that you provide as the first argument with each item in the source array. Then it looks at the return value from that function call. If it's a truthy value such as a number, a string, or true, then the current item we're looking at will make it into the filtered array. However, if the function call returns a falsy value, then the item is discarded. In this example, our source array has 5 items in it. We call filter on it and we provide a function as the first argument. This function will be called once for each item. X will be equal to the current item that we're looking at, and we return the result of this expression. So on the first call, X will be equal to 1. This will return false, so this item is discarded. When it's called with 2, false again, 3, false again, but finally 4 and 5 will yield a true value from this expression, so that those 2 items will make it into the filtered array. That's why when we log this to the console, you can just see a new array that contains the items 4 and 5. Note that this is actually a new array. If we log items to the console just above it, you can see that the original is untouched, but we have our filtered array below. Now let's look at some of the various ways you can use filter. Here we have an array of objects. They represent people, they have a name property, and a pets property. If you wanted to create a new array that only contained those people that had pets, you could call filter on the people array, provide a function that checked the length of that pets array. If we log that to the console, you can see we only get Shane and Simon, and we don't get this person. Remember that you only need to return a truthy or falsy value to the function that gets called for each item. And because calling length on an empty array will return the number 0, this is a falsy value, and that's why this works. If the data you were working with instead omitted the pets property if a person didn't have any pets, how could we filter that? This wouldn't work because we're calling length on a property that may or may not exist. If we run this, you can see we get an error. Again, we can leverage the fact that we don't need to return a strict true or false to the filter method. We could simply say x.pets. If the pets property does not exist here, this expression will return undefined, which is absolutely fine for the filter method. It will simply exclude the item, which is what we wanted in the first place. So if we run that again, you can see it works. Now, as with most array methods, the real power comes when you begin chaining methods together. Here we have an array of lessons. Each item has a title, a view count, and an array of tags. We have 3 items in the array category, and then we have 1 item at the bottom that's in the functions category. So let's mimic a simple search functionality. We want to filter these lessons based on a tag that was given, and we'll also filter for popular videos, so we'll use 1000 as the baseline. So we want a new array that only contains items that are in the array category with a view count over 1000. So how would we go about this? First, let's set up the variables. So we'll say that the min views needs to be 1000 and the search term is array. Then we can set up our new filtered variable, which is the result of calling lessons filter. The first thing we want to do is remove anything that's not in the array category. We can do that by simply saying x.tags indexof search term is greater than -1. So this is the expression that we return. For the first 3 items, it will be true, as the word array exists in each of these. Then we can filter again. This time, we only want items that have a view count that's greater than our min views variable, which is 1000. So this will exclude this first one. We want to change the order of the results so that the most popular is first. So we can call sort, provide a comparative function, and we want them to be in descending order. So we can say b.views minus a.views. Following this, we can call map, provide a template string, and put a bit of HTML in here. We can use the title property, and then finally join it together with a new line character. Then we could log to the console another template string. If we run this, you can see that we just have two list items here that are sorted based on which had the most views. So to recap, we start with an array of objects like this. We first filter out any items that do not contain our search term in the tags array by calling indexof and checking its value is greater than -1, which means it does exist in the array. We call filter again and we check that the view count is more than the min views variable that we set. Then we sort the results using a numeric sort. At this point, we just have the array of two items. We call map on that, which returns a string of HTML. And then we join them together with a new line character. This is just for display purposes here. Finally, we log to the console and pass our filtered result. It's worth noting here that we call filter twice. Technically, you could provide a regular function here and do both checks inside the single function call. And you would absolutely want to do this if you have thousands or millions of items to iterate over. However, for small collections of data, you're not going to see a difference in performance. So if it's more readable to you, by all means, call filter more than once. ArraySum accepts a function as its first parameter. It will begin to call this function once for every item in this source array. Should any of those function calls yield a truthy value, then sum will return true. So in this example where our source array has 5 items in it, we call sum on the items array. X will become equal to each item in this array. So first 1, then 2, then 3. So on the first call, X will be equal to 1. This expression will return false. So we'll move on to the next item. X becomes equal to 2. This returns false again. We move on to the next. When we move on to the third item, this expression will now be true. So the process stops and sum returns the value true, which we assign to the has3 variable. So if we run this, you see we get true. If we provide a number that doesn't exist in our array, like 6, we get false. So ArraySum is great for a quick and dirty query on the array when you just want a yes or no answer. So let's put this into practice. Here we have an array of tasks. They each have a title and a completed property. We look in the DOM for an element with the class taskList here, and we build up some HTML by mapping over these tasks and wrapping those that are completed in a strike-through tag. So that handles the rendering of each item in the list. But we want to add a global modifier class to the list if all items are complete, and a different modifier class if there are any items left uncompleted. This will allow us to use some CSS to change the style. So we can do this by adding to the class list. Then to determine which class we're going to add, we can call tasks.sum. Here we'll have access to each task, and we can return task.completed is exactly equal to false. So because the sum method returns either true or false, this line will return true if any of our tasks are left uncompleted. If that's the case, we can add the class taskList uncompleted, or the inverse of that will be taskList completed. We hit save. You can see we now have taskList uncompleted. If we change this to true, we get taskList completed. So this will allow us to add some CSS to change the look of this when all tasks are completed. For example, if we were to put taskList -- completed, color light gray. And there you see we have the grayed out list. So this is a great example of when you should use array sum. When adding a class to our list, we were always going to add either uncompleted or completed. We didn't care what the title of any of these items were, or if they had any other properties. All we really cared about is whether a single one of them had the completed property set to false. Once we knew that, we could then decide which class to use, and we have the whole piece of logic wrapped up in a couple of lines. Another place you might use array sum is to guard against duplicate entries. So if we go back to just this tasks array, let's say we had a function called addTask in which you give it a title, and this will push onto the tasks array a new object that contains the title that you passed in and completed false as the default state of this task. Now if we call addTask with feed the dog and then log the tasks to the console, we can see we have the original 3 plus this one we added here. So far so good. But what if we wanted to check for duplicates? We change this to feed the cat. We run this and you see we now have duplicate entries. We can use array sum to guard against this. Inside the addTask function, we could exit early if an item with this title already exists. So we can say if tasks.sum, access each task individually, and compare the title to the one given in the function call. So calling sum on the tasks array will cause this function to be called for each of these items. Task.title will be equal to do laundry, feed the cat, watch the array lessons on Egghead. And we compare each of those in turn to what was passed in here in the function call. And then because sum returns either true or false, it will allow us to return early if the given title matches any that already exist. So in this case, when we call it with feed the cat, it's only going to make it into the second item where this will become true and we return. So if we run this now, you can see this is free of duplicates. Now of course, you could in here have some logging, or if you're in the browser you may put a message to the user, some sort of temporary error to say there's a duplicate. But the key thing to take away here is that especially now with ES 2015 and these arrow functions, array sum is the ideal method to use when you want a simple yes or no answer from querying your array. Array push is used to add elements to the end of an array. So if we wanted to add a third pet to this pets array, we could simply call pets.push and then provide a value. Log this to the console. You can now see we have the cat, dog, and hamster. Note that calling push on an array is what I would call a destructive update, meaning that the original array is actually modified in place. And this may be the behavior that you require, but it can also be a source of bugs. So that's just something to keep in mind when using push. Now, one of the more interesting facts about array push is that it can take any number of arguments here. So if we pass a second and run that, you can see that both items have now been added to the source array. So it's exactly equivalent to doing this. Now that we know that push accepts any number of arguments, we can apply a little trick to enable us to merge two arrays together. So let's pull these out and pretend instead these are in a wish list. And we'll add another one just to illustrate here. So we'll add a snake. Now to merge these two arrays together, we can call apply on the push method, pass in pets as the context, and then the wish list. If we log this to the console, you can see now we have all 5 items. So this is a big improvement over the previous example, because using this technique, both the wish list and the source array can now contain any number of items and they'll still both get merged together. This works because calling apply and passing in an array like this is exactly equivalent to doing this. But obviously the benefit is that you don't have to know what these items are ahead of time. Now let's see it in action. Here we have a text input, a button, and a list. And to show array push in use, we'll use an array to represent the list items. So when we type into this input box and click add, we'll push the value onto the array and then display them in the list. Then in the JavaScript, we first get a reference to each DOM element that we need. Then we initialize the pets array. We add an event listener to the button so that we can respond to clicks. And then we have a render function that takes the pets array, generates a list item for each element in it, joins them together, and then sets that as the inner HTML on that list. So the first thing we need to do is check there is actually something in that input box. So we can say if input.value.length is greater than 0, then we want to add the value onto the pets array. And that's where we use push. After adding the item, you probably want to reset the value inside that text field. You can do that by setting it to an empty string. Finally, we want to call render to show the results on screen. If we reload, type dog, click add, you can see dog is added to the list and this is emptied. Now we can add cat and you can see that we are building up this array. Array map creates a new array that is the same length as the original. It will call the function that you provide here once for each item in the source array, and it will use the return value to build up the new array. So if we log this to the console, you can see we get 2, 4, 6, 8 and 10. So this function was called 5 times, and for each call, item became equal to first 1, then 2, 3, 4 and then 5, and we return the result of multiplying that by 2. And that's why we get this array. This doesn't affect the original array. If we log that above it, we can see that the first array is still intact. Now, it's important to understand that it doesn't matter what you return from this function, the new array is always going to have 5 items in it. So even if we remove this function body altogether, which would make this function return undefined, and log that to the console, you can see that we get an array of 5 undefined values. So this is the key to understanding when map is the appropriate array method to use. And here are some examples. Let's say you have an array of string values like these, but inside your application you need them to be numbers so that you can perform calculations with them. So this is a perfect use case for map because we want a new array of the exact same length but with different values. So what we want out of the other end of this is simply the numbers 1, 2, 3, 4 and 5. So to implement that, we can return a call to the number constructor and pass along the item. This will convert the string to a number where possible, and if we log that to the console, you can see we now have 1 through 5. And just to make it clearer, we can log the original array and we can see that they are strings and these are numbers. So now that you understand this one-to-one mapping, you can start to come up with some really nice, concise code. Let's take, for example, an array that has 2 names in it, Shane and Sally. This first one has a couple of whitespace characters and there's one here also. Now we want to create a new array that has those 2 strings but trimmed. So we'll say the mapped array is equal to items.map, and now we're going to use an inline arrow function and we'll just call x.trim. If we log that to the console, you can see we get exactly what we expect. So this function will be called twice, x will be equal to this string first, we call .trim on the string, which will remove this white space and return it. The same thing happens to Sully, this is removed, and now mapped contains the items we expect. So this is nice, but we are just scratching the surface. Let's take this array of 2 names, and let's say we want to convert those 2 names into 2 person objects, so that later on in our code, maybe in the UI or something like that, we can say person.firstname. Okay, so again, this is a perfect use case for map because we have an array of 2 items and we want to create a new array that is going to use those 2 items as a base. So if we say mapped is equal to items.map, and actually for this example, we'll change this to names. Then inside the callback, we'll have access to each name. And here we have the opportunity to return an object instead. We'll create the first name property and set it equal to name, and then log that to the console. So now you can see the new array contains two objects with the name set as the first name property. And just to make this clearer, we can access each item maybe as you would later on in your application. Here we have a person, and if we just log person.firstname, you can see that we have the desired result. Another common use case for map is to add fields onto objects so that they better suit your application. For example, let's say you receive this array from an API. It's two objects with first name and last name properties. But in your app, when you display people, you always use the full name. And you may end up with some code like this. I'm just logging to the console for demo purposes, but this could be inside a component or something like that. Here we're just adding the first name, a space, and the last name. So if we use this quite a lot in our code, it would be much better to have a full name property on these objects. That way we can just do full name. Okay, so let's add that property using map. We'll create a new array called mapped, and we'll call items.map, and we're going to return a new object that has a first name property equal to the first name property of the incoming object. The same for last name, and then the full name property, which we'll create by adding together the first name with a space and the last name. So now when we access this new array later on in our code, we have access to the full name property, as you can see here. Sometimes you'll want to take an array of objects and just pull off a particular value from each object. Take this example. Here we have a function that creates a HTML list. It just takes an array as a parameter, and then it wraps each item in an li tag, joins that together as a string, and then adds it in the middle of these two ul tags. We can see it in action by calling it with an array, and we'll say cat and dog. Log it to the console, and you can see we get a ul and the two list items. The whole point here being that you can pass in any number of items and they will be wrapped appropriately. Okay, so how could we use this same function to print out a list of first names? Your initial thought may be that you could just pass in the items array here and then come into this function and modify it. So instead of simply using x, you can do x.firstname. And that does actually work, as you can see here. But we have now completely changed the implementation of this create HTML list. We've explicitly tied it to objects that have a first name property. So we can't use this elsewhere in our app. We may as well change this to be create person list. But we don't want to do that. So how can we get around this? Well, this is where we come back to this idea of pulling values from objects. So let's create another mapped array. And we're going to call items.map. And we'll use the shorthand arrow functions again. This time we'll just access the first name. And that will be enough. Because now, if we log mapped to the console, you can see that we just have Shane and Sally. It doesn't know anything about these objects anymore. It's just two string values. So then we can pass that into our function, as we did with the cat and the dog. And of course, we need to remove this first name. And we're back to where we were before. Of course, the difference is now, this does take any array of values. So it can take our mapped array, or it can just take an array of cat and dog, and you can see it still works. So whenever you have an array of objects, and instead of that you just want a simple array of a value from each object, this is all you need. Finally, as with all array methods, the real power comes when you begin to combine them together. So let's modify this example slightly, just to make it a bit more readable. We're going to put new lines in between these LIs, and we're going to stick a new line here and after the list there as well. And we'll even just pad this in a bit. Let's log it to the console again, and we can see we have a nicely formatted list. Okay, to show map in conjunction with other array methods, let's pretend we have a chat application and we want to just list the users who are currently active. So we'll add an active property to each person, and then we'll add a third person who we will set to inactive. Okay, so at the moment if we log this, we're going to get all users, but we want to filter out any that have the active property set to false. Well, this is extremely simple. We just call filter here, And because we're calling filter before we do the mapping, we still have access to each full object. And because the filter method just expects either a truthy or falsy value, we can return x.active. Log that to the console and you can see we get what we wanted. So this is the real power, because look how declarative this is. We take the items array and we filter it based on whether or not the active property is set to true. That will omit this object. So when we get to this line, we're only going to have these two items in it. So then calling map here is going to create an array that just has Shane and Sally in it. That means when we finally call this function, we don't have to worry about this person because they were excluded further up the chain. The every method returns true or false based on whether or not every element in this source array passes a condition that we provide here as the return value to this function. So in this example, we have 5 items, which means this function will be executed 5 times. X will become equal to 1, then 2, 3, 4, then 5. And because all of those items are less than 10, this will return true, which we set to the result and log to the console, which you can see here. Now, if we were to change this to instead be 5, so now we are saying, is every item in our array less than 5? Well, you can see that the first 4 obviously are, but this last one isn't. So on the 5th run, this will return false, which will cause the every method to return false, and we should see that if we log it to the console, which we do. Now, the interesting thing about the every method is that it will exit on the first failure. So in this example, it's the last element of the array that's causing this to return false. But what would happen if we remove this from here and instead placed it at the front? If we log that again, you can see we still get false, but something very different has happened behind the scenes. So let's just put a tiny bit of logging in place to make this clearer. If we log called with and then the value that we're currently looking at, and then we'll still return that same conditional. So x less than 5. If we run this again, now you can see that this function body was only executed 1 time. Because it returned false the very first time, it doesn't need to look at any more items in the array. But if we stick it back on the end and run it, you can see that now this function body was executed once for each item. So this could be important if your application is doing something that is quite expensive inside these checks. It's nice to know that it will exit on the very first failure. Now you should just think of every as a way of providing flexible validation for your arrays. Let's look at another example where we have an array that contains strings and numbers. If you wanted to validate that it only contains strings, you could simply say type of x is equal to string. And then if we run that, you can see we get false because this isn't a string. If we remove that item, we get true. Every can also be used to fill in the gaps from the data you have to work with. So in this example, we have an array with 2 objects in it that represent form fields. We are not given any information about whether or not the entire form was valid. We're just given information about each individual field. So it's up to us to infer the state of this form. Well, we can do that really easily with every, simply by saying is valid is equal to fields.every. Then we need to provide the condition. So we'll say x.errors.length is exactly equal to 0. So if every item in the fields array has an empty array under errors, then we would consider that form to be valid. If any of the fields have errors, then it will be invalid. So if we log this to the console, we can see that this is indeed not a valid form. The beauty of this is that we've been able to infer the state of the form simply from the data provided to us. And now we can use this to conditionally add a header to the form that warned the user that there were errors below. Another example could be tracking a user's progression through a course of videos. Let's say that this array represents the course and each object is a video. They each have a title and a length. This is how many seconds are in the video. And then viewed is the amount of seconds the user has actually watched. Now to determine if this course is complete from this data only, we would have to check the viewed count against the length. So we could say is complete equal to videos.every, and our condition is that the viewed count is exactly equal to the length. Log this to the console, and you can see that no, this course is not complete because there's still a minute of this video to watch. If we were to up this to 420, now you can see it's true. Now, as with before, we now have the state of this course, even though it wasn't given to us in the data. And we can use this to display like a little green tick or something at the side of each course to show when it was completed. One final thing to mention about the every method is that if you look at this conditional that we provide here inside the callback, these are very similar to the type of conditions you provide to array filters. So it's sometimes worth extracting them out to separate functions so that you can reuse them. For example, look what happens if I just change this method call here to filter. Log it to the console, and you can see that we're actually getting both items because we changed these values. But if we switch this back and log it again, you can see that we're only getting the completed videos. So we haven't changed any of this logic, just changed the method here. So to enable us to reuse this, we can simply pull it out into a separate function. We'll call it complete. Pass in X here, and then change this back to every. Pass complete there, log to the console again, and we're back to where we were earlier. Is complete is now false again, but now if we also wanted to have an array of just completed videos, we can reuse the logic in this function simply by saying videos.filter, passing in the same complete function. Log it to the console, and you can see it works. If we wanted to create a sum of all of these numbers, we would take this items array, call reduce on it, pass in a callback function that has two parameters, the previous value and the current item that we're looking at, and we return the result of adding the previous value and the current one together. Log it to the console, and we get the correct result. And the interesting thing about this example is that this callback here is only actually executed 4 times, even though we have 5 items in this array. This happens because for every call, we need access to both the previous value and the current one. But for the very first call, we don't have a previous value. So what it does, it takes the first item of the array, provides that as the previous value, and then it takes the second item of the array and provides that as the current. Let's sketch this out. The first time our callback runs, we need a previous and a current value. So we'll take those two there, and we'll call our function with 1 and 2. So this now represents this. So you can see that on the very first call, you're going to be adding 1 and 2 together and returning that result. So this returns 3. Now, the second time it's called, we now have a previous value here. So we pass that in along with the next item in the array, which happens to be a 3. So this is the second function call. It's the result of the previous one along with the next item in the array. This returns 6. The same thing repeats. We take the result of the previous call, pass it in there, then grab the next item in the array. So that's 4. This returns 10. It happens one final time. So the fourth function call will get 10 and the last item in the array, which is 5. This returns 15. And because this is the last item of the array, this value will be returned and it will be set to this constant sum. To prove this, we can provide a small piece of logging inside this function instead. So if we break this out, we'll return the same expression, but before we do that, we'll log out the previous value and then the current item that we're looking at. And when we log that, you can see we just get the 4 function calls, but the really important part is that for the very first one, it's taking 2 items from the source array, and for all the other calls, it's using the return result of each call along with the next item in the array. As well as your callback, reduce actually takes a second argument that's optional, but if you provide it here, I'm going to use 0, it will actually use this as the previous value. So we often talk about this as the initial value, or the seed. But either way, this is saying for the very first function call, don't use 2 items for my array. Instead, use this value as the previous and then use the first item in my array. And this is very different because now this function body will be executed 5 times, once for each item, which we can see if we log this to the console. We get that extra function call where we have 0 provided as the previous value, which is coming from here. Now on to some practical examples. Here we have an array of albums. It's 2 objects that each represent an individual album. They have a title, images property. Images is simply an array of file paths. Now if we wanted to count how many images we had in total, that's a great use case for reduce. So we can say that num images is equal to albums.reduce. Then we provide a function. We have our previous value and the current album. In our callback, we're going to return the previous value plus the length of the current album's images array. Now before I run this, can you spot the mistake? We haven't provided an initial value here. So on the first call, previous is actually going to be equal to this object, and album here will be equal to the second object. So we'll be trying to add an object to the length of the second images array, and the whole thing is just incorrect. So we need to provide a 0 here, as we're expecting a number to be returned. This will ensure that previous here is equal to 0 first, and that this gets executed twice, so that we can look at the length of this array, add it to the length of that array, and return it. So now if I log this, you can see we get 5. And if I remove this initial value, we get this strange result here. Now reduce is not limited to just adding numbers together. You can use it to accumulate all types of values, like arrays for example. Let's say you wanted to create a new array from this that just contained all of the images in a single flat array. Well, let's walk through it. First we'll just change this so it makes more sense. We'll just say it's images. Now our initial value does not want to be a number this time, actually it wants to be an empty array. So for the first call, previous will be equal to this empty array. So what do we want to do? We know that when it's called the second time, we're going to expect an array with these 2 items in it. So if we return previous, which is an empty array at this point, we'll concat onto it the current album's images. If you pass an array to the concat method, it will pull out each of the values and add them individually to the array that you are concating onto. So after the first call, we'll end up with an array containing these 2 images. That will be passed into the next function call as the previous value, onto which we concat these 3. The end result, if we log it to the console, is a single flat array containing all of the images. We can also use reduce to build up objects. Let's say you have the following data. An array of users. Each object has an ID and a name. Now let's say that within your application you wish that you could access your users in the following way. Users, ID, and then name for example. But this wouldn't currently work because we're dealing with an array. So you would have to filter it first looking for the ID, and then you have to access the first result of the filtered array, and it can be tricky. So what you really want is the data in this format, where users is actually an object, and you want the ID to be the key of each user. This will allow you to easily access each user if you know their ID without having to filter. We just need to transform this original array using reduce. And to do that, we'll say that new users is equal to users.reduce. And then the value we're building up is an object, so we'll just call it object. And for each call, we'll have access to the user. We need to pass in a new object as the initial value so that we can add our users to it. So on the very first call, object here will be equal to this, but we get to look at this item. So what we can do is use a square bracket syntax to add a new element to this object. And we can use the user ID, and we'll set that equal to the user. Then we return the object. Note that we don't put a return statement here because setting a value on an object does not return the object on the left hand side. So we wouldn't be able to accumulate the value. So we just set a new property on the object here equal to the user and return it. Now if we log this to the console, you can see that we do have a new object. It has two keys, O1 and O2, and they are equal to the user object. But the important part is that now if we want to access the user with an ID of 02, for example, we could just go new users 02 and access their name property. And we get the result we expect.